when Napoleon lay at Boulogne for a year with his flat-bottom boats, and his Grand Army, he was told by someone, there are bitter weeds in England. There are certainly a great many more of them since the British Expeditionary Force returned.
The year is 1946, and the world is trying to catch its breath after the most devastating conflict in history. A new world is emerging, eager, uneasy, and ready to move forward. In London, the British Prime Minister is overenthusiastic about forming friendly relations with the Soviet Union. The war is over, but the peace is uncertain. Britain is keen on helping Stalin and cooperating however possible. So, in an act of goodwill and also naivety, Britain decides to export one of its most advanced technologies, the Rolls-Royce Nene jet engine, a marvel of post-war British engineering, and at the time, the most powerful jet engine in the world. Officially, the Soviets were meant to use it for civilian aircraft, but within months, they reverse-engineered the design into the Klimov VK-1. That engine ended up in the MiG-15, a jet that would tear through American and Allied aircraft in the Korean War. In one of the greatest strategic blunders in aviation history, Rolls-Royce had unknowingly armed the enemy. 2 decades on, Rolls-Royce was once again on the edge. But this time, the threat wasn't foreign. It was internal. They had promised Lockheed a revolutionary engine, the RB-211, a technological leap that would change the face of civil aviation. It didn't go to plan. In 1971, after a cascade of engineering failures and budget disasters, Rolls-Royce went bankrupt. The British government was forced to nationalize the company to keep it alive. But that wasn't the end. Far from it. From the ruins of the RB-211 came the foundation for what would become one of the most successful jet engine families in history, the Trent series. Today, this name is synonymous with efficiency, quality, and endurance. So, how did that happen? How did a company that once armed the enemy and nearly destroyed itself become a leader in aviation? Let's find out. But before getting into that, how about you hit that subscribe button? If you're fascinated by the engineering marvels that power our world, this is the place for you. Now rewind all the way back to 1914, the World War I era. You see, long before it was building jet engines for the skies, Rolls-Royce was earning its reputation on the ground. Founded in 1906 by Charles Rolls and Henry Royce, the company quickly became known for building the best cars in the world. But Rolls had more than just roads in mind. Charles Rolls was obsessed with flight. In fact, he was one of Britain's earliest aviators. In 1910, became the first man to fly non-stop across the English Channel and back. And then World War I happened. Britain's interests weren't in luxury cars and fancy automobiles anymore. What it needed were powerful, reliable engines for its military aircraft. So Rolls-Royce seized the opportunity and delivered just that. The first aero engine, the Eagle, was created. From that point on, aviation became more than a side project. Through 2 world wars and into the jet age, Rolls-Royce engines powered icons of the sky. From the Merlin in the Spitfire to the Welland, Britain's first jet engine. By the mid-20th century, Rolls-Royce wasn't just a car company anymore. It was a symbol of aerospace ambition. This time, engineers around the world began looking at a new kind of propulsion. One that didn't rely on spinning propellers, but raw, compressed thrust. And once again, Rolls-Royce was at the forefront of Britain's aviation evolution. The concept wasn't originally theirs. Credit goes to Sir Frank Whittle, the RAF engineer who pioneered Britain's first working turbojet. But Rolls-Royce had something Whittle didn't: industrial scale. The company took over development of Whittle's designs and, in 1944, delivered Britain's first production jet engine, the Welland. It powered the Gloucester Meteor, the Allies' first operational jet fighter. With it, Rolls-Royce had officially entered the jet age. From Welland came the Derwent, and then the Avon, an engine that would power dozens of aircraft around the world. From British Canberras to Swedish fighters, and even early commercial jets. By the 1950s and 60s, Rolls-Royce wasn't just making engines, it was shaping national air strategies, supplying the Royal Air Force, and exporting to key allies. The company even worked with Bristol, de Havilland, and Armstrong Siddeley, eventually absorbing all of them. But it wasn't until the late 1960s that Rolls-Royce promised something never seen before. That promise was the RB211. It was the late 1960s. Commercial aviation was booming. Airlines wanted faster, quieter, more efficient jets for long-haul travel. Lockheed was building the L-1011 TriStar, a wide-body airliner meant to rival the DC-10 and Boeing 747. And they needed an engine that could match their vision. So, as you can understand, Rolls-Royce raised its hand. Their proposal, the RB211, a triple-spool turbofan engine. It was radically different from anything else in the skies. How? You see, most engines had two shafts. The RB211 had three, each spinning inside the other at different speeds, improving efficiency at every stage. It also used a new material, high-fill, a lightweight carbon fiber for the fan blades. It was futuristic, bold, and, well, unproven. That's where the problems began. During high-speed tests, the carbon fiber blades shattered. They couldn't handle bird strikes or high-stress loads. Rolls-Royce had to switch to titanium, a safer but heavier option. But this switching also meant re-engineering the entire fan system, which equaled unbelievable costs. And it wasn't just the blades. The whole engine was too heavy, too expensive, and too late. Each month of delay bled millions. By 1971, Rolls-Royce was losing £1 million a day on the RB211 program. With no rescue in sight, the company did the unthinkable. On February 4, 1971, Rolls-Royce declared bankruptcy. One of Britain's most iconic engineering firms, founded in 1906, was insolvent. The British government had to nationalize it. Rolls-Royce was simply too important to fail. Not just for prestige, but for jobs, military contracts, and Lockheed's airliner program, which now hung by a thread. Ironically, once the company was saved and the RB211 finally entered service, it worked. It was quiet, fuel-efficient, and incredibly reliable. Airlines loved it, and more importantly, it became the foundation for something far bigger. From the RB211 would evolve a new generation of engines, the Trent series. Engines that would one day power the Boeing 777, the Airbus A350, and make Rolls-Royce a dominant force in civil aviation. It was the 1980s. RB211 had been a huge success. But despite all that, Rolls-Royce's share of the large civil turbofan market was only 8%. General Electric and Pratt & Whitney dominated the skies, so the company scrambled to produce a modified version of the RB211. They began experimenting with higher bypass ratios, advanced fan blade materials, and increased thrust classes, all still based on the RB211 core design. This led to the creation of the Trent 600 prototype in the late 1980s. It never entered service, but it laid the groundwork for a new family of engines. In 1995, the Trent 700 became the first commercial member of the new engine family. powering the Airbus A330. Though more advanced, it shared the RB211's DNA, triple spool design and modular components. Each spool operates at optimal speed, low pressure, intermediate pressure, and high pressure turbines. The result? More efficient compression, better fuel economy, and greater reliability. In 1995, the Trent 700 entered commercial service aboard the Airbus A330. It was a hit. Airlines praised its efficiency and quiet performance. Next came the Trent 800, which powered Boeing's new 777. By then, Rolls-Royce had cemented itself as one of the big three engine makers alongside GE and Pratt & Whitney. With each new variant, Trent 500, 900, 1000, and eventually the Trent XWB, Rolls-Royce pushed further into the long-haul, wide-body market. The Trent 900 powered the massive Airbus A380. The Trent 1000 took on Boeing's Dreamliner. And the Trent XWB, designed for the Airbus A350, became the most efficient large aero engine in the world when it entered service in 2015. The Trent series also had Trent 7000, which was exclusively manufactured to power Airbus A330neo. In essence, the Trent series wasn't a departure from the RB211. It was its evolution, each version building on the lessons, data, and core structure of its predecessor. By the mid-2010s, more than half the world's wide-body aircraft were powered by Rolls-Royce engines. Over 400 airlines worldwide fly with Trent engines. And thanks to long-term maintenance contracts called Power by the Hour, Rolls-Royce doesn't just sell engines. They sell uptime, efficiency, and trust. The Trent series turned a near-death moment into a legacy. It transformed Rolls-Royce from a recovering British manufacturer into a global aerospace leader. And it all came from the wreckage of a failed carbon fiber fan blade. That's not just engineering, that's resurrection. But even the most advanced machines face their moments of failure. And for Rolls-Royce's Trent engine series, those moments did come. In 2008, British Airways Flight 38 crash-landed at Heathrow. Both Trent 800 engines had lost power on final approach. Investigators found that ice from the fuel system had broken loose and clogged the fuel-oil heat exchanger. But this wasn't just a one-off. Similar problems were later found in Trent 500 and 700 series engines. Rolls-Royce responded with a major fix, redesigning the heat exchanger faceplate to prevent ice blockage. The result? A flatter surface, improved reliability, and an industry-wide update mandated by regulators. Then came November 4, 2010. Qantas Flight 32 takes off from Singapore's Changi Airport en route to Sydney. On board, 469 passengers. Just minutes into the climb, one of its four Trent 900 engines explodes. Shrapnel tears through the wing and fuselage. Critical flight systems fail. But thanks to the skill of the crew, the aircraft returns safely to Singapore. No one is injured. Investigators traced the failure to an oil pipe that was manufactured incorrectly and which cracked under pressure. That led to leaking oil into the hot turbine section and igniting a fire. This incident was a blow to Rolls-Royce's reputation and credibility. It led to the grounding of Qantas fleet, as well as Lufthansa and Singapore lines. Then came the Trent 1000, the engine that powered Boeing's 787 Dreamliner. In the late 2010s, a new issue emerged: premature blade cracking in the intermediate pressure turbine. It wasn't catastrophic, but it was disruptive. Airlines were forced to ground planes, flights were delayed, and Rolls-Royce's reputation took a hit. The company redesigned the blades, added new inspection regimes, and paid out millions in compensation to affected operators. These weren't just engineering faults. They were public moments of reckoning. But they also pushed Rolls-Royce to become more transparent, more rigorous, and more resilient. So what's in store for the company? It's the new state-of-the-art jet engine, UltraFan. This isn't a variant. It's not an upgrade. It's a reimagining of the jet engine, a machine that could define the next 30 years of aviation. At over 140 inches in fan diameter, the UltraFan is the largest engine Rolls-Royce has ever built. But its size isn't about muscle, it's about efficiency. Its massive front fan and ultra-high bypass ratio, which is 15:1 compared to 10:1 on the Trent XWB. This allows it to generate more thrust using less fuel. The goal? A 25% improvement in fuel burn compared to first-generation Trent engines. What makes UltraFan revolutionary is its geared architecture, and that's a first for Rolls-Royce. A reduction gearbox sits between the fan and the low-pressure turbine, allowing each to spin at their optimal speed. UltraFan isn't just about new mechanics, it's about new materials. The fan blades are made of carbon titanium, 20% lighter than traditional materials and stronger under extreme loads. Inside the core, ceramic matrix composites replace metal in hot zones, resisting heat far better and allowing higher operating temperatures essential for cutting emissions. Perhaps most importantly, UltraFan is designed to be modular. The same core technologies can be scaled down to power smaller single-aisle aircraft, which is traditionally dominated by Pratt & Whitney and CFM. This is Rolls-Royce's first real shot at cracking that market, and they're not holding back. In 2023, UltraFan turned for the first time at full power on Rolls-Royce's new test bed 80, the largest of its kind in the world. It worked, and it worked beautifully. Today, Rolls-Royce is betting big. UltraFan represents billions in investment and a decade of work. It may not fly commercially for a few more years, but when it does, it could redefine aviation economics. From gifting jet engines to a Cold War rival, to the bankruptcy triggered by a bold promise, to powering the most advanced aircraft in the skies today, Rolls-Royce has lived a life few companies could survive, let alone define. It didn't start as an aviation company, and yet, through war, politics, and financial collapse, it became the symbol of high-performance aerospace engineering. Each engine wasn't just a machine, it was a gamble, a test of courage, of vision, and sometimes of survival. The RB211 nearly killed the company. The Trent 1000 cracked under stress. And the UltraFan? Well, that one isn't flying yet, but it might just be the most important engine Rolls-Royce has ever built. Because now, the challenge isn't just speed or power, it's sustainability. It's about building engines for a world that's running out of runway. Rolls-Royce isn't just chasing the future, it's helping shape it. And that's what makes this story remarkable. Not the failures, not even the triumphs, but the persistence. Because this is the story of an engine that refused to die, and of the company that kept it alive. If this story moved you, if you love the hidden history behind the technology we take for granted, let us know in the comments below. We're just getting started.